Good morning, good afternoon, and good evening. Welcome back to Chapter 18. We're up to annelids. Annelids are the segmented worms. This is our first group of organisms with segmentation. You might remember the tapeworms. They looked like they had segmentation, but it's not true segmentation. Remember, the segments on a tapeworm were just reproductive structures. Those prolatids just self-contained reproductive cells, reproductive units. With segmentation, with the segmented worms, segmentation is repeated units, repeated body structures. All organisms that come after this, you'll see these repeated body structures. And what these repeated body structures do is they make injuries less lethal. With a roundworm, with cnidarian, if you pierce it, all of the guts, all of the internal fluid just come flowing out, and then that's it. It's just dead. With an earthworm, if you pierce it, you damage that one section, but you don't kill the whole animal. It's really a big deal, this concept, this idea of segmentation, of making a bunch of repeated units, and we'll look at it in just a minute. Like the cephalopods we just got done talking about in the previous video, annelids have closed circulatory system. The difference is that all annelids have closed circulatory systems, and only the cephalopods within phylum Mollusca, only the cephalopods have closed circulatory system. All the rest of them have open. I forgot to write it down. My bad. So this is phylum Annelida. Some people say phylum Annelida. Phylum Annelida. About 20,000 species of annelids. In this picture, we can see a number of things. Here's a really big earthworm. This represents, or this shows those segments, all those little grooves, all those little ridges that you see on an earthworm's body, that represents the segment. And if you follow that inside, each one of those little dips, each one of those little grooves is because there is a segment, a body wall, right immediately underneath of that. And so each one of these is a separate segment. Here we see the circulatory system of the earthworm. You've probably heard that earthworms have like 9 hearts or something. Well, these things right here are the hearts. It doesn't look like a heart you've ever seen, and we'll talk about this when we talk about the circulatory system in a couple chapters. But their heart is really just a muscular tube that just squirts. So it's not actually 9 hearts like we have a heart. But anyway, here that is. There is the brain of the earthworm, and remember we showed the brain in the mollusk. It was just that ring that went around the digestive system, and then those 2 nerve cords came off. Here is also the brain. It's also in the shape of a ring that goes around the digestive system right here. And then here's that, they only have a single cord though, not 2. Here's that single cord going down the belly of the animal. And we talked about this. We said that invertebrates, humans and other vertebrates, we have a dorsal nerve cord. It runs down our back. They've got a ventral nerve cord that runs down their belly. Here we see that septum, that wall, that segment that separates the different segments. This little green thing here is basically the beginnings of a kidney. And one of the interesting things about it is that it actually filters the fluid from the chamber in front of it, and then it releases the fluid out the back. Nothing important, no big deal for us to talk about, but it's just kind of neat that they filter the fluid from the chamber in front of them. All right, so this is a breakdown of a segmented worm. Our first group, our first class of annelids are the polychaetes. What does poly mean? Poly means many. And the polychaetes, Polychaeta, class Polychaeta. Chaete means, it comes from the word setae, which means hair. So polychaete literally means many hairs. About 10,000 species, give or take, of bristleworms. These are almost all marine. Polychaetes are almost all marine. We call them bristleworms. Here are some pictures of some polychaetes. In their own strange way, some of them are really pretty. This big fan worm right up here, these are its gills, actually. These are those setae. Kind of interesting that this is a worm. I mean, if I had asked you, if I just shown you a picture of that and tell me what kind of organism that is, you'd probably say it was a plant or something. But it's not, it's a worm. Here's a great example of a polychaete. We can clearly see those setae, those little hairs and coming off in tufts off the side of the animal. And also we can clearly see the segmentation. Clear segmentation, clear setae. This is a bloodworm right here. Bloodworms are, they're often used as bait in a lot of places. Bloodworms are polychaetes. This right here are the mouth parts of a bloodworm. See those 4 fangs they use for biting into stuff. Kind of gruesome. Polychaetes. If polychaete means many hairs, our next group, our next class is called oligochaete. And oligochaetes, oligochaeta, oligo means few. So polychaete means many hairs, oligochaete means few hairs. Oligochaetes are earthworms. Polychaetes are marine segmented worms. Oligochaetes are terrestrial segmented worms. About 10,000 species of oligochaetes. They're usually hermaphrodites. When you look at a picture of an earthworm, you usually see that little smooth section. And whenever they draw a picture of them, they always show a collar, right? A collar. The collar on the earthworm is called the clitellum, and underneath of the clitellum is where the sex organs are. And yeah, earthworms are mostly hermaphrodites, which means when they have sex, both of them go away and have babies. Here's a kid holding a giant earthworm. Here's another woman holding a giant earthworm. So, polychaetes, bristleworms, mostly marine. Oligochaetes, earthworms, mostly terrestrial. Our last group of annelids are the hierodinians. Class Hierodinia. These are the leeches. Only about 700 species. Remember, we have like 10,000 species of earthworms, about 10,000 species of polychaetes, not even 1,000 species of leeches. About 700 species of leeches. They're all carnivorous. Most of them are parasites. They're not all parasites, but they're mostly parasites. They've got 2 suckers, one at the head and one at the butt. However, only the one at the head is able to suck blood. The one at the tail is really just a suction cup. It's just for attachment. They are, for the most part, freshwater oligochaetes. Freshwater annelids. So 3 basic places to live on Earth: saltwater, freshwater, or land. Polychaetes are saltwater. Oligochaetes are land. Hierodinians, leeches, are freshwater. They've been used in medicine for centuries. Here we see the leech is attached at both ends, but remember, just the one at the butt is simply just a suction cup. It's the one at the mouth that is the one that can draw blood. This guy, he's not a quack, he's not a crazy doctor, he's holding a jar of leeches. The scientific name of these things is medicinalis, which means medicine. These are medicinal leeches, and leeches are still used in medicine today. Way back hundreds of years ago, if somebody was sick and had a fever, they would bleed them, or they would put leeches on them to leach out the poison. We don't do that anymore, obviously. But we do still use leeches in medicine, and the way we use leeches in medicine is it's actually easier to reattach a limb than it is to reattach a digit. The arteries and veins in a limb are big and easy to see, and so you can stitch them back together again, and eventually they will heal and you'll have a working limb again. The arteries and veins in a digit are a lot smaller. The arteries are big enough to be seen, and so you can reattach those easy enough. It's the veins that are the problem. The veins are much thinner, they're much smaller, and they are much harder to reattach. So you can get fresh blood out to this reattached digit. But if the veins aren't attached very well, then the blood can't get back out again. And so what happens is the blood begins to kind of build up in the digit. And if the blood builds up, fresh blood can't get in there, so eventually the digit will starve. And so what the leech does is they take the leech and they put it on the reattached digit, and the leech will drink the old blood out to allow good blood to come into the digit. And eventually, if you give the veins time, they will reattach, they'll regrow. So kind of weird or gross or yucky or whatever to imagine that you can have a leech on you in the hospital, but they're actually used in legitimate medicine. And this is just a picture of a Russian woman who likes to have leeches on her. Those aren't pimples, those are spots of where leeches had attached to her, and it might be proof that there's too many people in the world.